Good morning, everyone. This is Sam Reed. I'm the Global Sales Manager for Cornell Dubilier Electronics. I want to welcome all of you to our review this morning, and thank you for choosing to spend this time with us. As outlined in the invitation, we'll be spending approximately 30 to 40 minutes presenting an overview of the Cornell Dubilier capacitor product range that may or should be of interest to anyone designing systems for military and aerospace applications. We certainly hope that you do see something that could help you with one of your projects, and if so, we're always available to discuss it in more detail. Our presenter today is Mike McGeachie. Mike is a Navy veteran who holds a BSEE from Clemson University. He's currently our Chief Field Engineer, and prior to that, he spent 28 years in aluminum electrolytic capacitor design engineering. In fact, Mike was involved in some way with most of the aluminum oxide dielectric capacitors you'll see in today's review. So at this point, I'll turn control over to Mike.
Good morning, all. I appreciate your joining us for this presentation. We serve a wide variety of markets. We're a pretty diversified company in our production. Of course, industrial covers a lot of ground. We are big in medical. We're big in Mil-Aero and in power management. So we're going to concentrate on that military aerospace segment today. We excel in capacitor technologies for critical applications. To support that, we have a fully certified mill test lab that allows us to meet various mill standards and certify parts against different mill standards. We are currently supplying capacitors for aircraft, both commercial and military. A lot of cockpit communication, a lot of power supplies for all kinds of things, displays, radars. And of course, we even supply parts for the big strobe lights on the wingtips and that sort of thing. We supply to naval, ship, and submarine applications, mostly power supply and inverters, some stuff in communication systems, and ground-based applications, radar systems, missile defense, mobile radios, military trucks and tanks. We do have our capacitors riding around on M1s and Bradleys and those sorts of things. We supply a lot of parts that have been specifically ruggedized for the more demanding military applications. We make parts that withstand higher vibration than standard industrial parts, wide temperature ranges. We do low temperature parts. We're in dielectrics that are not typically extended into those ranges. And we have been doing a lot of work in high temperature and make parts that go up to 200 degrees C. Most of our parts have been certified for minimum 80,000 feet in altitude, which covers pretty much all manned aircraft flight envelopes. And of course, we do high reliability, long life work. We develop greater stability over operating temperature ranges, hermeticity, doing established reliability testing for critical application parts. And of course, we still supply your terminals if you so need with some minimum content of lead to address the tin whisker issue. And of course, we save you space and we save you weight, because certainly in all aerospace applications, those two things are some critical questions that are always asked. How do you save some weight out of your box? How do you make it more compact than it was? We use 4 principal technologies in military aerospace applications: aluminum electrolytics, both large screw terminals down through custom size prismatics down to little surface mount capacitors. We do RF Mica capacitors. We're the primary supplier in the world for this dielectric. It's very stable over a very wide range of temperatures and frequencies. And it's a good alternative to some of the class 1 ceramics that are out there. a little better on things like cracking and that sort of thing that you deal with than with ceramics. We do a lot of specialty film work from some relatively small, AC pulse capacitors to large steel cased, welded steel cased capacitors for different applications. And then, of course, we're getting into supercapacitors. These are becoming more common in military and aerospace applications as they become more available. They sort of sit in a space between what we traditionally think of as capacitors and a battery. So you have aluminum electrolytics, which are typically thought of in units of microfarads or perhaps millifarads. You have RF mica capacitors that are usually discussed in picofarads. You have films that are in, hundreds of nanofarads to low millifarads. And then, of course, you have supercaps, which are often rated in farads of capacitance per case. We do make a lot of rugged aluminum electrolytic capacitors for various applications. We can discuss with you your various vibration and vibration tolerances and look at changes that we may need to make to a standard capacitor to survive your more harsh environment. We are currently cataloging capacitors up to 175 degrees C in this market. And of course, we sell entire lines of capacitors that are good down to minus 55 C. And most of these capacitors, we've gone ahead and gone through an altitude test. It's a fairly straightforward test, so we just sort of test our entire product line against that test. We have decades, and that's literally decades, 5, 6, 7 decades of experience of supplying military capacitors, both mil standard capacitors and then other capacitors that are designed specifically for a given military application. We maintain a QPL for mil capacitors so that we have a full set of reliability testing ongoing all the time in the lab. We offer a wide range of sizes from 3.5 by 9 inches tall down to what's about a 10 by 10 millimeter surface mount capacitor. And we offer voltage ranges from 6.3 up through 550 volts as standard catalog items. We have built some 600 volts and even some 650 volt capacitors. We are not currently cataloging that option, but if you have a need in that option, we can discuss with you where we are on supplying those capacitors. We do make large capacitors that are as high as 3 farads. In comparison to supercap, this 3 farad capacitor at 16 volts would be 3.5 by 4 1/8 tall, or excuse me, 8 1/8 tall. If you took that 3 farads in a supercap, it would be half an inch in diameter and an inch long. Ruggedized screw terminals. We offer standard lines that do minus 55 to 105, minus 55 to 125 in screw terminals, and we do radials in a minus 55 to 105 package. All of these can be manufactured in high vibration variations for higher environments, and that would have to be specifically addressed by a particular design. Size, of course, matters. The larger the physical capacitor, the more difficult it is to survive higher vibration demands on that capacitor. So sometimes the answer to your vibration problem is going to be that you're going to have to use 3 capacitors instead of 1, so we can make them small enough to control the vibration effects. Our Flatpack aluminum electrolytic capacitors that we launched about 30 years ago, MLP being military low profile. These capacitors are half an inch thick and a prismatic shape, so they are very efficient for your typical board applications for aluminum electrolytics. They are flying in essentially every military aircraft in the fleet, and they are also on most of the, showing up on most of the various military vehicles. They're widely used in things like heads-up displays and night vision systems and alternative vision systems. Because of their small size, they're easier to design around. And we do have both an 85°C offering and a 125°C offering. They are very efficient for form factor. You can stack these, and of course, if you're going to run them hot, they are quite easy to heat sink because of their shape. Cylinders are historically quite difficult to heat sink. So the solution typically on cylinders leans more towards trying to move lots of air past them. Not always a possibility in some of these military and avionics applications. You simply can't generate the airflow. We continue to develop this. About 3 years ago, we raised the stainless lifetime from a 2,000-hour MLS to a 5,000-hour MLSG. And we get very superior low temperature impedance up through 250 volts. And some of the sizes we can take the vibration tolerance as high as 50 Gs. That would be sinusoidal, 10 to 2,000 hertz. We make custom assemblies. Each one of these boxes shown actually has aluminum electrolytic capacitors inside it. The large one has actually the flat capacitors in it, the MLP capacitors. This box has 5 radials in it, obviously designed to fit in a particular space. And these little boxes have a custom built internal capacitor that is inside of these, so that each case is isolated from the capacitor itself and therefore groundable. We have come out with a hermetically sealed aluminum electrolytic. This is a first in the market for that. And it replaces 3 or 4 D size or T4 TLM capacitors as shown here. There's some interesting effects when you start looking at these kinds of capacitors over temperature range. TLM capacitors have relatively poor cold temperature cap retention. So in an application where your capacitance is being driven entirely by a minimum capacitance requirement that you have to meet at -55°C, these are good alternative. Here we're going to show you a comparison of 4 T4 wets, basically 4,000 mics at 40 against a 2,200 mic at 40 MLSH. At room temperature, obviously the tantalums have more capacitance, but in lower voltages, the tantalum density is higher than it is for aluminum electrolytic. It's in the nature of the dielectric. But these capacitors have lost. These are actually from test data that we ran. The tantalums lost 68% of their capacitance by the time they got to -55. So at -55°C, the MLSH has more capacitance remaining than the tantalum bank. Plus, it's half the weight and a third the cost. One of our new products, for which we got an Electronic Product of the Year award in 2018. The 85°C offering is 8.2 millimeters, so we're continuing to shrink this flat form factor that we've come up with. The 105°C offering is 9 millimeters. The 105°C offering has been generated by putting a stainless steel sleeve on the aluminum can to give it more stiffness. Okay, primarily these capacitors are going to be used for big bulk storage and for filtering, and it's a good alternative to arrays of surface mounts and radials and axials. You get an improvement of reliability by reducing part count, and you can reduce weight and space and cost. These 3 boards here all have 5800 mics at 35 volts on them. So they are essentially the same capacitance and voltage. And as you can see, we've saved about 70% of the board space by eliminating all that space that's between all these parts. And of course, in some of these capacitors, 40% of the capacitor itself is not capacitor. It's various cells and pieces. Only about 10% or so of this capacitor is something other than capacitor. Continuing on that same theme, we launched our ULP, which is we've changed the way that we are packaging the aluminum electrolytic in order to achieve these very thin 2 and 3 millimeter thin packages. We have put the actual capacitor inside a polymer pouch, much like you would do with a battery, and then we put that inside of a metal case to give it a form stability. But the metal case is not in and of itself a seal. The internals are sealed as a heat sealed polymer. We were awarded again an award in 2019 for this product. It's rated at 3,000 hours at 85 degrees C. And again, you're going to reduce part counts and fit these into spaces where you perhaps didn't realize you had some space. The original customer that we discussed this particular design with actually put the capacitor in the lid of his box. This is a flex circuit that goes into a ZIF socket on the board. And so the plan was to allow him to put this into his lid, make the connection up to the board, and then close the lid and screw it down. So he essentially was able to harvest some space in the upper part of his box that was not ordinarily available without some real strange, daughter board arrangements to get something into that space. And then our very latest in our flat form factor, this is about 1 millimeter thick. It is essentially a single layer of aluminum foil with a couple of copper cathodes. This is an aluminum polymer technology, so this is a completely dry technology. And because it's an aluminum polymer, its ESR is very low, its impedance is very low. Therefore, you can run a great deal of ripple current through this capacitor. The one shown here is about 4 inches square, but this is made using a stacking technology. So theoretically, we can kind of make this to whatever space we need to make that. Doesn't have to be square, could be round, could be oblong. In theory, we could make one that actually has a hole in the middle, and we could actually make it not flat. We could make this in a crescent, say, if that matched your available space. Now it's not flexible. The polymerization does not allow you to flex this capacitor, but we could make it into a particular form if you have that application need. And we did win a 2020 LEAP Award for this capacitor. And this capacitor is rated for 2,000 hours at 125 degrees C. We have just launched this product recently. We're actually up to about 4,000 or 5,000 hours of life test in the lab. So these capacitors are showing very long life, high temperature sustainability. And then we go to the very smallest end of the spectrum. These are little surface mount capacitors. They have higher vibration tolerances than a standard surface mount. And we have both standard solids and also hybrid polymer technologies in this marketplace. All of these capacitors are rated at -55, and some go as high as 125 degrees C with a hybrid polymer. What we've done to achieve this is we've increased the stability of the part in the carrier by raising the size of the carrier around the capacitor, and then at the same time improving the solder down portion of the lead we actually have metal pads embedded in the nylon carrier so that you actually solder the carrier to the board to give it greater stability. And then we actually improve the connection that comes out of the inside to a thicker diameter to give it more stability and more resistance to movement internally. Mica. Mica is a different, completely different kind of dielectric. It is a naturally occurring substance. The particular grade of mica used in capacitors is only available in a few places in the world, but and we get most of ours from India. It is very stable because it's a natural mineral, and because of its very low or very high Q, I guess would be a better way to say that. You can use this in applications up to a gigahertz. So it shows up in radios, communication equipment, and even sometimes in lower end radar and IFF type equipment. It's very stable over wide temperature range for temperature and voltage. Robust packaging from the very beginning of this type of capacitor, because from the very beginning these were mill type capacitors. It's a wide temperature range. It can be minus 55 to 125 degrees is the standard. We do make them up to 150 degrees C in custom applications. The capacity tolerances can be, plus or minus 0.5% on these types of capacitors, and so they're good. They're good alternative for Class 1 ceramics in that usage space. And of course, we do have established reliability for mill applications. We actually still maintain some mill standard capacitors. They're most often, you see them in onboard communications and radars, some in power supplies, but mostly in RF circuits. And of course, we sell to pretty much the whole gambit of defense contractors in this market space. One of the things we offer is a Mil-PRF 39001, which is a standard mill standard. These used to be mill standards, now they're Mil-PRFs. And this is a dip. The mica is put in here in a chip carrier, and then it's dipped in a ceramic coating to protect it from the environment. We do burn-in and testing on these, so there's a QPL system for these capacitors, and there's still a fair amount of these things used in a lot of different communication systems. We offer a chip, a surface mount chip mica capacitor, as everything has moved to surface mount. It's an alternative to MLCCs. It avoids the cracking problem. You don't have a cracking problem with the mica, and you don't have that same piezoelectric effect that you can get with the MLCCs. It's often used for signal decoupling, antenna waveguides, that sort of thing, and of course for bandpass filters for high frequency applications. You sometimes see them used as snubbers, small snubbers. A lot of things in avionics instrumentation, RF instrumentation. And then of course metal clads. This is a custom market space. We clad the basic mica capacitor in a metal clad, so it runs cool. For a given load, you can really get a lot of heat out of this. They're mostly in silver-plated brass cases, so they act like little mini heat sinks on your circuit board. And of course, because they spread that heat, they remain cooler. They are a high Q product. Or the way to say that is they're very low resistance, and they generate very little internal heat. So you see a lot of it in microwave, power supply amplifiers and transmitters. Small radios, 10 to 200 watts. Handheld, manpack, vehicular base stations. They're carried airborne, they're carried naval. Of course, they're also in commercial radios. They've been used in telemetry applications, and they are an alternative to ceramic and porcelain chips. Film capacitor technology. This gets into larger capacitors as well as just your standard board mount capacitors. We sell a lot of these capacitors for DC link and for snubber. It's a very low loss dielectric, so it carries a lot of power density, allows you to get large discharges. So it is used in strobe lighting, and it is used in pulse networks, including, in fact, rail guns. Where you have a half a tractor trailer truck of capacitors in order to give your signal to fire your railgun. We make all kinds of custom packaging in this market space, from simple, wrap, what we call wrap and fill, which is basically we take the film winding and we put a tape on it that's wider than the winding, and we fill the ends with an epoxy to seal it, up to welded metal cases for these types of capacitors. It's been designed and tested for challenging applications. We do, in fact, have our capacitors in use with railgun applications. We also use them for, electromagnetic launchers, for things like drones and things that have to be launched, rather than where there's not access to runway space to launch that drone. Supercaps. Supercaps are kind of new to the market space in the last decade or so. The typical cell is 2.7 to 3 volts. We have just recently launched a new 3 volt form factor in our radials. Some of the larger ones are in the traditional snap case, where they have a snap lead. Smaller ones are in radial cases with long leads. Used in a wide variety of places where you need particularly where we need a lot of holdup, and in places where a battery might not work as well. The supercapacitor is more tolerant of lots of charges and discharges than most battery technologies. So in systems where you're going to charge and discharge it fairly often, it's a better choice than a battery in many cases. You see it for things that have to be autonomous. And was released from source of power. It supplies power over a long time, using guidance systems and UPSs, and we've even sold it for some fire suppression systems out there in that marketplace. It is a rapidly growing and rapidly changing marketplace. We have just brought on somebody specifically to work in this market space, to give us greater technologies for not only selling supercapacitors, but selling banks of supercapacitors to achieve higher voltage levels, so that you're not just locked at 3 volts or 6 volts, but you can build a 14 volt or 28 volt or 40 volt bank of capacitors and have that function for you as an independent system. We do have a military certified test lab. We can do shock testing up to 500 Gs. We can do vibration, both random and sine. We do have a number of thermocycle chambers that allow us to do thermal cycle testing, humidity testing. So like the 85 testing that's becoming more common, we are set up to do that, do moisture resistance testing. In addition to, having, 60 hertz, or really it would be 120 hertz coming out of the rectifiers for doing ripple testing. We also operate some 400 hertz generators specifically to give us that capability to do ripple testing at 400 hertz. And we do have systems set up to do pulse discharge testing for a wide variety of capacitors in that space. Most of our main lab procedures are based on Mil Standard 202, because that's where we started when we were putting all that together 40 years ago. And of course, Mil Standard 790, which would be practices, and then various individual Mil standards and Mil PRFs that call out specific tests. So any sort of Mil test that you have, we can certainly discuss getting it done. Most of the standard tests we can do in-house. Some of the custom testing we may have to send it outside. But we certainly have people here who speak the language of Mil documents. You know, I came out of the Navy. We have other people who came out of the Army. So we have people who are familiar with those types of documents, how they're structured and how they're satisfied. And thank you.